Hi children, this is your physical science facilitator from Commander Group of Schools. Welcome to the online classes. In the last class, we learned what is motion, what is rest, how these are relative, and about distance and displacement. In this class, we are going to discuss about average speed, average velocity, directional velocity, uniform speed. If time supports, we'll go for the acceleration also. Right. For example, if you project a body into the air like this, in this direction, what happens? It will move. It will move like this and will reaches somewhere else. So from point A, you projected the object with some elevation with respect to horizontal. It's about this horizontal. Okay, it's making some angle. You projected with some angle. But after some time, the body is moving like this in a curved path. In a curved path that reaches another point B. Let us consider one more point here as S. Now consider from this what you learn, this AB. What is this AB? Shortest distance between starting and ending points. This one, this yellow color. Is about shortest distance between starting and ending point in a specified direction. So that it can be considered as a displacement. Now what about this A, S and B? A, S, B, this part. It is about distance. It is about distance. Okay. So similarly, if you consider few more examples, okay, where the direction is changing and how the distance and displacement is going to be different. For example, maybe a car. Here there may be a car like this. A car. A car is moving on the surface of this road. It is moving on the road like this. It is at the point A. Present, it is at the point A. And it has to reach point B. And the distance between this point A to B is around, let us consider it as 270 kilometers. Assume that 270 kilometers. This entire distance from A to B, the distance is about 270 kilometers. The car has covered entire distance in 9 hours. In 9 hours. In 9 hours, it covered 270 kilometers from point A to B. Okay. So after 9 hours, what is the placement of the car here? Now, what is the distance it covered? Sorry, what is the speed of the particular vehicle or nothing but the car? What is the formula of speed? Is distance by time. So from this, how we have to define the speed? The distance covered by a body in particular time. The distance covered by a body in particular time. For example, in 1 second I completed 2 feet. So 2 feet per second is my speed. Okay. So the distance covered in unit time. The distance covered in unit time is called its speed. Generally, to cover 270 kilometers, it may not maintain the same speed. First it may come with 100 kmph, later it may come 40 kmph, sometime it may be rest, again its velocity has increases. So to cover A to B, it maintain different velocities. It has different velocities. So for that, what have to be considered? Average speed. Average speed, the total distance and the total time that we have to be considered. So what is the total distance it covered? 270 by hours 9. Result 0. So 30 kilometers per hour is the average speed of particular car. Okay. Right. So average speed is the total distance. Suppose it has been covered in total time. What is the total time it has been taken? So the total time to be considered and the total distance we should consider. So the speed can be defined as the total distance by the total time will be the average speed. If we consider average velocity, the same thing will be considered where the body is moving in a specified direction. Okay, if your body covers some displacement with unit time, or the displacement covered by a body in unit time. Okay, displacement is certainly have to represent with direction, yes, because it is a vector quantity, right? So how we can define that velocity or the average velocity here? Average velocity. So previously speed. What is speed? Distance and time. So the total distance covered in total time. Similarly, average velocity means the total displacement covered in total time. Total displacement, total time. Then you will get average velocity. What is average velocity? The total displacement covered by a body in total time. If you consider only the speed and velocity, but commonly not going to be considered the speed and velocity. Most probably it have to be discussed about the average only. But the question will be given, what are the differences between speed and velocity? They may ask like this. What is meant by speed? Yes, speed can be defined as, what is the definition? In the first point we have to define. First point is regarding to the definition. First point. What is the definition, mark? The distance covered by a body in unit time. The distance covered by a body in unit time. Okay, that is about definition. How to write in terms. Okay, how to write it in terms now. The speed can be defined as that. This is not right. Speed can be defined as, how can you define? The total distance covered when in unit time. Okay. Similarly, when you go for the velocity definition, the velocity is defined as, how have you defined that? The total displacement covered in unit time. That is also called as total time. Then you can consider about the average velocity. Commonly they ask speed and velocity, but it is very difficult to identify the particular speed, particular velocity. About instantaneous you are going to identify. So that average speed and average velocity. That formula. Second one is about formula. Speed is equal to distance by time. Here, velocity is equal to displacement by time. After the formula, units. What are the units here? Distance. Distance units is meters. For time units is second. Here also displacement is in meters by second. And the last one about nature. What is the nature? It is about a scalar quantity. It is a scalar quantity. Why it is a scalar quantity? Because it does not have any direction. And it is a vector quantity. Velocity is a vector quantity. Okay, these are the differences. First point you have right, definition. Second point is about formula. Third point is regarding to the units. Fourth point is about nature. Okay. So don't forget the keywords. Then it is very easy to remember. And we are going to distinguish. Better to go for the subheadings also, because our presentation should be separate. If you want to become a star student, the superior presentation is needed, textbook reading is needed, and regular to the school is also needed. For that, our presentation will be different ways. Okay, so you have to use some techniques. So, 4 keywords: definition, formula, units, and nature. From that, we can differentiate the speed and velocity. Right. Then, what is the particular direction? Said that velocity is a vector quantity. Vector quantity means it should have S direction. So, how the direction changes? For that, we will see. Yes, we will see about that. If I am going to rotate this one like this, now it is rotating. No. So, when it is rotating, at any one case, at any one point, if I release this one, then what happens? It won't rotate. From where I leave this, from their point, from that particular point, it will move the tangential. It will move tangential direction. See, yes. From that point, it moves straight. Okay. So let us see that. Like this, the body is moving. Continuously, the body is moving. Okay. Near circular motion. Near circular path. It is the object. Let us consider. If we release the force from here, from this point, it will go in tangential direction. It will go in tangential direction. You know about the secant and tangent. Secant is just one node into touches just on the circumference at one point. Secant is it will intersect. Right. Now it is a tangent. So from where you remove that force, from that point, for example, if I leave the force here, from this point it will move in this direction, tangential. For example, if I leave the force here, it will move in this direction. All are tangential directions. Okay, so from that particular point, the direction of the velocity, like this, tangential direction. Remember the bit? If the body is in circular motion, if you leave the force, the body will move in tangential direction to a particular circular path. Okay, why it's go like that? Okay, I'm done. One thing is important here. Without any external force, any body is under motion. Have you given an example? Without applying the force, if any object is getting the motion, no chance. Only in the movies it can happen. Okay, come like this means the chair may move in movies, but in normal cases it cannot move. Because unless you are applying the force, nobody will get the motion. For example, the boat now it is under rest. I am going to push it down, it is going to vibrate. Okay, now it is at rest. If I am going to apply the force, it is moving. So until and unless the application of force, nobody will get the motion. Of course, if you release the object, it may fall down because the gravitational pull is there, gravitational force is there. So if any body is under motion, certainly there will be force. Nobody will get the motion unless the application of force. Okay. So for example, let us consider an object is moving like this. Straight road. The road is straight. After some place, the road has taken a curve. There is a turn like this. A vehicle is going like this. Now a vehicle is going like this. Okay. So for example, a bike or a bicycle. Bicycle is moving like this on the road. Now the road is a left turn. So it has to move the left turn. Certainly what you have to do? You have to apply some force to make it into turn, to move in a curved path. So initially the body is in linear motion. It has to move in a curved path. Yes, sir. So we have to change this linear motion into circular motion. Linear motion into circular motion. So suddenly what we have to do? We have to apply some force. So we have to convert the linear motion into circular motion. We should apply some force. Similarly, the body is in circular motion. When you release the force, it will move in tangential direction. Means the body wants to move in tangential direction, but what you are doing? You are applying some force to move in a curved path. So what you have to do? We have to apply the force which acts towards the center. This force is called centripetal force. Centripetal force. So with the help of the centripetal force, what you are doing? You are rotating the particular object with the help of centripetal force. So you release the centripetal force, it will go in tangential direction. So the body is moving in the tangential direction. To avoid that, we are applying some force, centripetal force. Of course, an acceleration also going to act here. That's what is called centripetal acceleration towards the center. Right. I think you understood why it goes in the tangential direction. Now, uniform speed. Uniform speed or uniform motion. Or uniform motion also considered. For example, there is a point A and B, which is about 60 kilometers. The distance is about 60 kilometers. And maybe a car, let us consider a car. This car covers same distance like this. It is moving this direction like this. It reaches point A to B in 1 hour, nothing but 60 minutes. So in first minute it covers 1 kilometer. In second minute also 1 kilometer. It is about again 1 kilometer in second minute. In third minute also 1 kilometer. In the fourth minute also 1 kilometer. Fifth minute also 1 kilometer. Sixth minute, so like that. So from this what you understand? 60 kilometers, 60 minutes. 1 kilometer, 1 minute. Another 1 kilometer, 1 minute. Another 1 kilometer, 1 minute, 1 kilometer. So the object is going to be covered equal distances in equal intervals of time. What is the time interval here? 1 minute. Here also 1 minute. Here also 1 minute. Here also 1 minute. Here 1 kilometer, 1 kilometer, 1 kilometer, 1 kilometer. So the distance is same. Time interval is also same. So how we can define this uniform speed now? If a body covers equal distances in equal time intervals, however the time intervals are very small, because if you consider about 60 kilometers 60 minutes, okay, 30 kilometers may not, 30 kilometers may be 40 minutes, remaining 30 kilometers may be 20 minutes. So here what is happening here? 30 kilometers in 40 minutes, remaining 30 kilometers only in 20 minutes. So here more speed, here less speed. It is not going to be considered as a uniform motion. If a body covers equal distances in equal intervals of time, however the time intervals are very small. If it consider 1 hour, equal distance, 1 minute, equal distance, 1 second, equal distance for the next time intervals also. Have understood? Okay. So what is the definition of uniform speed? If a body covers equal distances in equal time intervals, however the time intervals are very small. That's what we call uniform speed. Now, non-uniform motion or non-uniform speed. For that, the same object, same vehicle is moving from one point to another point. Okay, here in 1 minute, 1 kilometer. Next, another minute. In the second minute, it covers 3 kilometers. In third minute, it covers 2 kilometers. In fourth minute, it covers just half kilometer. So like this. Time interval is same. 1 minute, 1 minute, 1 minute, 1 minute. What about the distance? 1 kilometer, 3 kilometer, 2 kilometer, half kilometer. Means for the same intervals of time, different distances it is going to be covered. Means if a body covers unequal distances in equal time intervals, unequal distances in equal intervals of time, then it is called non-uniform speed. Non-uniform speed. Okay. Similarly, uniform velocity will also come like that. That instantaneous speed is there. To find that instantaneous speed, we are having, of course, in all the vehicles we are having speedometer. Okay, from the speedometer we can identify that instantaneous speed. Okay, so if we consider about with the help of a graph how the body is moving and how it is going to be identified with the help of x and y axis. Yes. For example, x on the horizon. Here I am going to take an x-axis, right? On y-axis, I am going to consider displacement. Displacement. Yes. And it's about maybe 1 second, 2 seconds, 3 seconds, 4 seconds. 1, 2, 3, 4. Time, of course, it is in seconds. Displacement, of course, it is in meters. I am going to consider meters. Here also 1 meter, 2 meters, 3 meters, 4 meters, like this. I am going to get displacement. Here, time. Displacement versus time. Displacement versus time is velocity. If I take here distance versus time, speed will come, right? So, if it covers first minute or maybe first second, it covers like this 1 meter. In first second, it covers 1 meter. In second, it covers 2. In third, it covers 3. Third second, 3 meters. For fourth second, like this, 4. Okay, so here it is this one, like this, and of course like this. When you join all these, you will get a straight line. A straight line means for equal intervals of time, it's going to be covered equal displacements. Equal intervals of time, equal displacements. So it can be considered as uniform velocity. Why I am writing velocity here? Because what is the thing I am going to consider here? Displacement. If the same graph is given for distance, then what you have to write? Uniform speed. Okay, understood? So it is about the body which is in linear motion. Uniform velocity. For equal intervals of time, it is going to cover the equal displacements. Okay, so that's what we call uniform current, uniform velocity. For example, if I write like this, say the nature of the object here, time in seconds or x-axis, and y-axis I am going to take the distance, of course in meters. 0, 1, 2, 3, 4, 5, of course 1, 2, 3, 4. Now the object, of course the graph is represented like this. Comment on the position or maybe the nature of the particular object. How can you say? For 0 second, 3 meters. For 1 second, 3 meters. For 2 seconds, 3 meters. 3 seconds, 3 meters. From this, what you can say? No? Is there any change in the distance? no change. With respect to time, there is no change in the position of the object. With respect to time, there is no change in the position of the object. Means the body is under rest. The body is under rest. Okay? Right. There is no change in the position. So like that, with the help of graph, we can identify different natures of the motions and etc. Okay? And some numerical problems are also there. We will see. For example, there is a kabaddi board like this. A kabaddi board is like this. A kabaddi board is like this. So in the beginning, the captain wants to do warm up. The captain wants to do warm up. Okay. So from here it is about 40 meters. Let us consider, not like that. First we will go for that. Approximately it is about maybe 10 meters, and here maybe 7 meters like this. Here also 10 meters, here also 7 meters. Okay, so the captain starts from point A and reaches again point A, again point A. Okay, here maybe it's about 10 before 17 seconds. He reaches it 17 seconds. Now calculate the speed and of course velocity. Average speed and average velocity. Average speed and average velocity. Right. So from here the distance. What is my speed? Distance by time. What is the distance here? 10 plus 7 plus again 10 plus 7 by time. What is the time? 17 seconds. So S is equal to total is 34 would you know? Yes, by 7. So how much it will be? 2 meter per second. So 2 meters per second is the speed. Now tell me what is the velocity? What is velocity? Displacement by time. So velocity is equal to displacement. It starts from A, again reaches to A. So displacement is 0 by 17 seconds. Anything by 0? 0. So there is no velocity. So velocity becomes 0 because there is no change in displacement. I think you may understood. The remaining numericals and the concepts can be discussed in the next class. Have a nice day. Bye.